this session, hopefully, going to start soon. And we're going to talk about from Dockerfail to Dockerfile, mainly the practices around, the practices around how to write a better Dockerfile, how to make production-ready Dockerfile, how to improve your developer experience while using Docker and Dockerfiles. And we're going to end up with probably a weird question. Do we ever need a Dockerfile? But you're going to discover the answer in the end. Here he is. Welcome. What took you so long?
Doesn't work. How are you doing, everybody? Nice. Thank you, thank you.
That's a nice way to apologize for you being late. But
okay.
yeah, nevertheless.
It's always my fault. That's
Absolutely.
okay. So, what's the agenda, Mohammed?
Okay, that was quick. So we're going to follow kind of the cloud-native way and or the Docker way of doing things: build, ship, and run. So this presentation is going to be basically split into these three main areas. In the build phase, we're going to discuss what bottlenecks, what problems, what issues Docker and Dockerfile brings while using them as development tools and adding them as one of the things, one of the dependencies in your development experience. How it's the issues that we have while asserting the Docker containers and the Dockerfiles that we build, the slowness that we experience sometimes. In the ship phase, how we can productionize those containers that we build, secrets. There's another session happening right there around secrets and security. So we're going to touch a little bit around that as well. Tags, how we can make them better, how we can productionize them. We're going to discuss some of the misconceptions and pitfalls of using tags. And finally, we're going to end with the run, how to run containers in production. Health checks, important to have checks, health around running your containers in production, but how probably a lot of people misuse them, that it's become, instead of a good technology, it becomes a bad one. Running some of the bad patterns, like running multiple processes in the container. And also, we're going to touch a little bit but this about security, but this time in production. And we're going to have a lot of demos. And Jalal is going to probably take care of that. He loves doing demos, so I can blame him if something fails, basically. But it's going to be using mostly Docker technologies. We wanted to keep this presentation and this demo tool agnostic, in a sense that we're going to focus on the Docker technology and the Docker ecosystem, but the principles that we give in this presentation applies anywhere. Whatever your container tool you are using, I know there are a lot of Red Hat folks, so Podman, same principles apply. If you want to run orchestration tools, same thing applies as well. Whatever your orchestration tools you use, Kubernetes, Swarm is probably not used anymore, but yeah, you got the idea. It's going to be also CI/CD agnostic. I could have used some fancy technology, but going to stick with the old gold bash script file, showing how you can automate basically most of the things that we can do, but you can add plugins depending on whatever CI/CD technology you are using that would help you to speed up and make more fancier CI/CD tools. But yeah, the same things apply. So we wanted to keep it basically agnostic and works everywhere, so we can have an idea of what we are talking about in this presentation. Moving on. Did I forget anything?
You could present yourself.
Yeah, no, but the demo part. I don't know. That's your laptop. I'm not going to take part of that. OK, this presentation, we're going to tell kind of a real story of a company, say startup, doesn't matter.
Not Spotify.
Basically a company that had a lot of brownfield application, has a lot of legacy, and then they have this new project that they're going to start, greenfield, right? That's what every developer dreams about. A new product coming in, we can use the new technologies, containers, fancy latest versions of whatever language you are using, use the latest libraries and stuff. And we have the green light from the upper management to use whatever technology we want to use. And we have been going to a lot of conferences, JNation, for example. We've been at conferences talking about containers and technology, and we wanted to use containers. So we have this small application. It's basically, can you have, what is the link for the application? It's here. It's here.
Yeah.
So basically, we want to build an application that is basically an awesome word. Basically, whenever you refresh the page, refresh manual, it gives you a selection of random words. It's basically 3-layer kind of application, back-end, front-end, and a database. So that's basically the requirement. That's basically what we're trying to build, right? So as any responsible developer team, we went to Google and we asked how we can put everything inside one container, how we can containerize this application, put both the front end, the back end, and the database into one container. So we put that into Google and Stack Overflow link. So we went to the Stack Overflow. Someone already asked the same question. We didn't read what it's about, and we found an accepted answer, right? So what we're going to do, as any responsible developer, we're going to copy this whole thing and use it. So this is going to be our starting point. Is the Dockerfile. Okay, wait, it's here. I want it to be here. It's going to be our starting point. So this is exactly what we're going to start about. This is basically our application, the DB word, the database. It contains a word SQL, basically a selection of words that we want to show. The web is basically a Go application wrapped in static files. The Go here is basically to have a small server that we can show the stuff that we are building. And finally, so the web, and then finally the backend is basically a Java application that expose some APIs, connect to the database, select the words, and send that, right? So basically, it works. So the demo that we shown earlier, basically based on this Dockerfile. It's not ideal, it's not perfect, but it works. Thanks to Stack Overflow, thanks to Google. Back to the presentation. And then, yeah, we show it to the clients, we show it to the boss, super happy. We deployed it to production, we run into a couple of issues, doesn't matter, who cares? The boss is happy. I got a raise at the end of the month. That's awesome. That's how we look. Everyone is happy. And what happens? The production, the application was great. We had a new requirement. We needed to add a lot of features. And then we started to stumble upon some issues. Typical, right? That's what happens in every single team that you're probably working on. And here would the fun start. The first thing that we run into is the developer experience. Adding Docker, adding Dockerfiles is another thing that's a dependency that you added in your developer workflow. That's another dependency that you need to manage. And now the Docker desktop, if you are using it, become a lot more annoying because it forces you to, it is every 6 months a pop-up that's coming that you need to update. And you need to learn Dockerfile. You need to read about the best practices of using Dockerfile. So if you see it or you compare it, it's basically not the same experience as using native tools. So Djalal is basically the experienced team or the experienced DevOps/SRE in the team. Yep. It's kind of the Jedi of the team. So we're going to throw to him all the issues that we're going to face. And hopefully, he's going to come up with some solutions. So Djalal, I'm trying to, if there are any improvement that we can make to make the developer experience of using Docker and Dockerfile sucks less.
Yeah. First, a show of hand, just to adapt to the audience here. Who's ever written a Dockerfile in his life? Okay.
That's the full room, basically.
Okay. Keep your hands up if you...
Wait a minute. Have you written a Dockerfile or copied a Dockerfile from Stack Overflow?
No.
That, OK. Who have copied a Dockerfile from Stack Overflow? OK, I did. Anyway.
OK. Keep your hands up if this Dockerfile is currently in production. Okay. Nice audience. All right. So my job here, as Mohammed said, is to make this Dockerfile very easy and harmless, and yeah, preserve your career in the next few years. So let's take a look at this Dockerfile that you gave me. It's really nice. I mean, it's working in production. It's making business run smooth. But one thing that I learned from you developers is that you should really check your code. So we have this good practice in code, Java and other programming languages, that we lint code. So what if there is a linter for Dockerfiles? Actually, there is. So let's use it. So this one, it's really a nice tool. It's called Hadolint, all right? So I'm going to demo what it does. All you do is feed him a Dockerfile, and it will give you feedback. It will give you instant feedback of what is right and what is not so right. So you don't have to, I don't know if everyone sees the screen. You don't have to...
is it visible in the back? Good, cool.
Yeah. You don't have to mess or try to guess. This tool, Hadolint, it has like dozens and dozens of rules. It's coded to detect anti-patterns and code smells, like Nat told us this morning. So all you have to do is run Dockerfile, run Hadolint until it's happy. So let's take a look at the new Dockerfile, because I tried to fix it. I had a couple hours, and yes, now it's happy. It says nothing, everything, all the warnings are gone. And what it does, it tells us about some good practices. So let's take a look at the step number 1. And my Dockerfile now is much more tighter. I mean, it's syntactically correct. It has all the nice versions. It doesn't have multiple copies. It doesn't have multiple runs. So that's the right way to write Dockerfiles. This syntactic check is very important from the beginning, so you could include it anywhere. And for now, we know that the production container is really the same as the developer production. There is no drift, there is no diverging build between my laptop and the production. That's nice for a start, right?
Yeah, not bad. And next slide. Yeah, the first part is what Nat called this morning during the keynote, the smells. How to make, how would your Dockerfile smell? Basically a lot of copy lines, multiples, which interdict and conflict with the concepts of layers of caching of Docker. We're going to get into that in a minute. But in this first iteration, we just used Hadolint, which is basically a linter. There's a lot of other tools available in the market out there. But what it enables you to do is basically a CLI tool that you can use it in your machine or your CI/CD on your build machine. And what it enables you to do, you don't need to be a Docker expert to learn all the best practices. Hadolint does the heavy lifting for you. Basically, do the checks, and it's really customizable. You can either make it as part of your pre-commit locally, so nothing goes to your Git repository until it's checked and verified, both syntactically and other semantic checks. And you can include it as part of your CI/CD pipeline, right? And you can customize it depending on the maturity of your team. There are, as you've seen, there are warnings, there are different levels that you can fail to. So you can start small, be more open to issues, and then you can enforce best practices slowly while your team gaining knowledge and confidence and expertise in Docker, which is really cool. So that was the first one. Wow, I need to slow down. The second thing is, when we build a Docker container, how we can assert that the content inside a Docker container is actually what we wanted it to be. Imagine how we can make sure that the executable that we added is there. How we make sure that the version of that executable is the same one that was generated in the content in our container. How to make sure that a folder that is necessary for our application to run is there. How to enforce security and write access to a folder or to a file or whatever in our container. Generally, what we used to do is to build the container, right? Spin up the container, SSH kind of, exec something, and then make the checks, verify it by hand. Now, if you do that one time, that's fine. If you do that dozens of times, doesn't matter. But how about if you do it every single time? From a security perspective, it is important. From a consistency perspective and reproducibility perspective of your container, it's also important. So my question to you, Jalal, how we can automate this process of checking what's inside our container?
Yeah, I'm very happy that you're very conscious about the challenges in production as a developer. That strikes me. So yeah, a short story. You have to include asserts. When you have a syntactically correct Dockerfile, doesn't mean that it contains the right things, because there could be something that you don't want to include and some other data that you don't expect. So what we're going to use this time is a tool called Container Structure Test. Container Structure Test is open source, is written by Google, and it can be run just like Aboullaite. You give him an image, an artifact, an OCE image, and it runs the image in a container, and this container then asserts many things, whatever you need. So how do we implement this? We just drop a little bit of YAML. Yes?
Yeah, I love YAML.
Yeah, me too. And this YAML contains whatever tests you can come up with. So you can test some metadata that you need the CMD to be supervisory. You can test file existence, and you can also test that some files are not in the resulting Docker image. So this is very powerful because it gives you confidence. It gives you, something as code, and I know we love everything as code. And it can also test any command that you can come up with. So right now I'm testing Postgres version, I'm testing Java version, and I'm even grepping through the output. Very powerful. You put it just near in the root of the Git repository, and your building script can then run it on any image that you just built. So now we have a syntactically correct Dockerfile and a valid content inside my Docker image. Very interesting in terms of quality, right?
Test. OK, now it's good. Thank you. Some of the smells and certain unwanted packages, you want to make sure that nothing in there that you don't need it. Because from a security point of view, anything that is inside your container, that's something that the provenance needs to be tracked, and you need to keep updating it and patching it for security vulnerability. So you don't want anything that has nothing to do with what your application needs to perform its function. Critical version changes, incorrect content, and what container test tool enable us to do is basically to automate this process. And automation is really important, so needless to say that. So it enables us to assert both the content and the version of what's inside the container. And again, you can run it both locally as part of your build process, and also in your favorite CI/CD tool, enable you basically to assert and ensure that the content you want to be in the container, it's what's inside your container. And the third thing, the more you add to the container, the more it grows. And we are developers, and whenever we need something, we just download it. And that's an issue for the A-series, because the larger your artifact is, the longer it takes to deploy it, and the more overhead it takes. And we're talking about nature, so if you care, that's a lot of footprints it left in there. So Docker came with the principles of layer caching. So how we can leverage that in order to improve the size of our image.
Yep. And this is a great source of frustration for everybody, devs and ops too. So what here I'm going to introduce in this step is using the two-step copy tip. It's a trick that you can use in your Dockerfiles. It's not something that Hadolin is going to tell you or container structure test is going to tell you, so just take it from me. It's my experience, and you will thank me later. So this one is going to impact directly our Dockerfile, where if I zoom here, see, the big change is here in these lines, where I'm making for the same Java jar a two-step copy. So I'm going to copy first the POM XML, which represents the external dependencies, and it's going to build and put it in cache. Okay? So that's the first step, and this cache is not going to move every day or even every week. So it's done. While the other part is the other source code that is really moving. And this one is copied separately, so that each time you code and you rebuild, all this is already done, and you just have here a very quick building step. And that is really drastically reducing our build time from like 1 minute and 30, depending on our test, to 30 seconds. So that's like 70% or so reduction. So this is a cool trick. You learn it by understanding what is a Docker image. It's composed of layers. So just use the layers, and you'll be very happy with the performance.
Yeah. The concepts of Dockers or Docker layers basically as a powerful concept, basically enable to cache the content. However, not a lot of tools allow us to do so, and understanding them and building those layers to speed up basically the build process and also to improve the final size of your image. So basically, what Jalal was saying is you want probably to put the files that are more likely to change at the bottom of your Dockerfile, at the end of your Dockerfile. That's the final layer, so you can cache the previous layers, and that helps speed up the build process. And the files that are less likely to change, which is basically your dependencies, change them once in a while. So those should go on the top. Your system dependencies should go on the top as well. So that's a simple rule of thumb to basically speed up the build process. So that summarized basically the issues that we're having in the first phase, which is the build phase. The team is happy. Now, it helped us to solve a lot of issues. Now we move it to, we want to take this and start to push in it. And one of the important factors in cloud-native era is, I'm losing sound. Oh, I'm cool. Is the ISO-like production. The 12-factor apps and a lot of cloud-native influencers say that in the cloud-native era, cool. In the cloud-native era, your final artifact, you need to be similar on the different environments you deploy your application into, right? The artifact that you deploy in production should be the same that you test in QA, should be the same one, more or less, that you deploy in the development. And what you change is basically the metadata and different configuration. That's a way to ensure that whatever issue you're going to run into production are basically the same. That's what the theory is. However, when you come to production, story is completely different. So how we can achieve this ISO-like production with less overhead on the developers?
Yep. Back to code, where we're going to talk about. We're going to talk about a nifty feature called multi-stage. So in multi-stage, it's been around since 2017, but it's still very, very very interesting. I'm going to basically take my Dockerfile and prep it for production. So it's the same unit. It's a Dockerfile, so you can patch it and code around. But now we are introducing multiple targets. The first one being the build stage, So it's the same syntax. But here you're going to notice that I have a second from. So the instruction from tells Docker to take a new base image and go go from start and start again as a new Docker image. What's the interest? What are we doing with this? We are reusing what happened in the build stage to copy something in the new Docker image. So that makes our images very slim and very production-like, and we then see that it's really production-oriented. I can even have here a last stage, which is called prod, and see how my dependencies now are very very little. There are only a handful of them. And I just copy the code that I built previously and run this in production. So this is very interesting to see. The Docker history command that tells us that in production, if you go with the current image, you have like a big chunk of 800 megabytes of something. It's the compilers, it's source code, it's build environment, it's developer libraries, anything that we don't want in production. That is quite dangerous because it increases the attack surface. So if I take a look at my new multi-stage image, I can see that the layers here are fewer, okay, but also way lighter. I don't have this 800 megabytes. I don't have some risks or of introducing vulnerabilities. And even if I tell Docker image to show the weight, I can see that it gets very interesting in terms of transfer. 1 gigabytes and something versus 600 megabytes. So only by touching this and rewriting this unique Dockerfile, I manage to cut the weight, network transfer, storage, and also increase security in a very significant manner.
Multi-stage build is a cool feature of Docker. Probably you're already aware of it. And a lot of people are using it basically to get rid of the build dependencies. So when you to build something, you don't need all the build dependencies. For Java, for example, you don't need all Maven stuff or Gradle or whatever your build tool is. You just want your final artifact and a Java runtime to run it. So it helps to trim the final size of your Docker image. However, no, go back. Still Docker. However, it helps to get rid of the different Docker/env environment that we have. Generally, one of the bad practices that I noticed in the industry up until now is for each environment you have a Dockerfile, which is like Dockerfile dev, Dockerfile QA, Dockerfile preprod, Dockerfile God save me,
no.
Where I am, hello, test. Can you hear me?
Oh,
okay,
you're
now
good,
yes.
You're good.
And by using multi-stage build, you can define targets. And those targets, you can leverage them. They're really powerful. You can leverage them to build artifacts. So you have one Dockerfile that basically run the word, and you can specify in your build command what target you wanna have. Because in real world there are some things that you want on your development environment that you don't want them in your production environment. You want all those debugging tools because you wanna, if there's a issue happening, you want to debug, you want to install some other things in your development environment to make it more easy to debug and understand what's happening. However, in production, you want to keep it as slim as possible. So having that flexibility while maintaining one Dockerfile is really good. Yeah, secrets. Secrets probably needs a session on its own, and that's what Brian is doing right next to us. But when we spoke about environments, one issue we definitely have is how we can include secrets for the different dependencies that we need. MQ probably, mail server, database, whatever. So managing those secrets and keeping them safe is really challenging, especially in dev environments. How a lot of the time we keep them in the code, which is bad. A lot of time we send them unintentionally to Git repo. So how we can improve our security in that manner.
Yeah. So the main principle here is that you don't have to guess. We want to remove doubt, fear, uncertainty. So once again, I'm going to pack my 8 years experience and give you the gist. So right here in my build, ship, run script, I included this nifty tool called Git Guardian Shield, GG Shield. So this tool, it's free. You can download it, and you have a very generous free tier. And what it does is that it scans all your Docker images for secrets, passwords, private keys, tokens, something that looks like a secret, and that shouldn't be in production, right? And it's very powerful because it does this by scanning all the layers. So even if you have a base layer with a secret and then you remove the secret in the following layers, it will still find it in the original layer. So that's very interesting, and that's why I'm including it in my my build, ship, run script. So yeah, that's as easy as typing any. No, not this one. Yes. So it's going to analyze and try to go all through the layers and finally tells you if something looks weird. So it had 100 and so candidates, but nothing was very bad, which is a good thing. So what can we profit from this, Mohammed?
Yeah, something important you mentioned is we generally check, when we run the container, we generally check the final image, which is basically the thing that got run in our production or at runtime. However, if you included a secret in one of the previous layers and you delete it afterward, it's there. It's in your Docker layers. Someone can go back, and we can show, if you type dive, a quick type dive command, you can basically go back, check all the layers, and check the content. So,
yeah.
So that's really important. So there is no delete in Docker, in the Docker containers. You can basically go back and check all the things that was happening, and someone can go in, download your container image, and go back and check all the secrets that you included. So that's something you need to be really aware of. So that's why Gshell basically go through all your history of layers and check them one by one to make sure that you didn't left anything there, and you didn't include anything there, which is really important.
One more thing.
Yeah?
The Docker secret, I forgot it.
Go ahead.
Yeah, so
No,
just to be complete, I skipped this, sorry.
No
Just to
worries.
be complete, now that we need secrets, who's going to create them, who's going to maintain them?
Yeah.
Not the devs. Okay, it's not their job, it's the job of sysops or SREs or what you want to call them. And we do create secrets like these or any other way, and we store them in a secure manner, in a native Docker manner or Kubernetes manner or in AWS, it's okay. And then we just reference these secrets for the service that's going to use them. So like this, Postgres now knows that his secret is available in this path. So that's the right way to inject configuration that is very, very sensitive.
Yeah,
Okay.
that is supported in our container orchestration tools. Kubernetes have it, Docker Swarm does as well. So it's the native way of creating secrets and having them. You don't need to manage your own, basically all containers tools, and there are like some extension that you can use if you want to have an enterprise version of it. Why are you speedy? Go back. Yeah, and Gshell, basically you can include it in your CI/CD pipeline. Always aim for automation. That will help you basically to free the time to pursue more innovative tasks. That was one of the keynote highlights. We have a quarter of an hour left, so we need to speed up a little bit. Tags. Tags are powerful and so underrated in probably in the software engineering industry, but especially in Docker. I don't know if How many of you overwrite tags or versions?
Of course.
Exactly. A lot of people don't know that you can overwrite tags and versions in Docker. So basically, it could happen that the version that you're running now, which is cached, could be a different version that is running in production because you managed to overwrite tags. And that is really problematic because the version that you tested in all the environments suddenly changed, and then you are running something else into production. So how we can basically enforce that?
Yeah, that's the few features in Docker that is not really shiny. For this, what my practice says is that you need to come up with your own tagging scheme. So I just did like a date-based tagging scheme. So if you go in this, yeah, if you go in, it's not here. It's
yeah, it's 6.
over
it's
there. Yes. Okay, I included it.
Are you
Yes. Okay. So I chose the timestamp as a tagging strategy. You could choose Semver, you could choose the Git SHA, you could choose the build number, anything, but it must have a one-to-one relationship with your code, with the latest with the state of your code. That's the good practice. Another thing is that when you build a Docker image, you include so many things that are not yours. And what is changing, what is evolving, what is updated on in your back, and you're not aware of it. So that's why we recommend that you include this Docker SBOM, the software bill of materials. I'm going to show you what it looks like. It scans your Docker image for dependencies, and it gives you a really great chart of whatever is running version by version. So I see here Perl and sed, and I was even aware that I included the tar, but I can take this and store it somewhere in the Docker, in the Git repository. And here I put it in the data. And base my versioning on a SHA or a digest of this content. So each time this changes, the digest changes, and I know that I'm tagging another version of my application. This is very important to kind of take something in production and go back to how it has been built, to troubleshoot, to see where the regression started, and other use cases. So yes, for this, Docker SBOM is very important to include into your build, ship, and run script.
Yeah. So SBOM is really important, especially from security point of view, and also reproducibility. That was a hard word. Reproducibility point of view, because you want to know what's running inside your container. If something changed, especially in the versions, because like there is a study that says 90% of the code that we run in production is not our code, probably more than that. So you want to make sure that the version that you are running, you know what you're running basically in production. So SBOM help you to achieve that. And it comes out of the box with Docker. with Docker. Again, use a tag strategy that would help you to have this one-to-one mapping. It's really important. Because like you can override the tags. Docker doesn't enforce that. Docker registry doesn't enforce that. A lot of registries that we use doesn't enforce it. So you can do that depending on the policy that you use, but make sure you have a one-to-one mapping. SHA-1 is one of the important ones and the easiest one to have because like it will ensure that you have one-to-one mapping. And also in your Dockerfile, the base image that you are using, probably avoid using a best practice is use the SHA-1 rather than tags. What's happened to your finger? Thank you. OK, so that summarizes the ship phase, and we're already running late. Now the fun part, which is running the containers in production. Next slide.
Yep.
And the first one is health checks. Health checks, we already know them, really important, because like we want to make sure that we are not sending traffic to our container unless it is running and ready to serve. But I heard that you can misuse them.
Yeah.
How?
It's very easy to shoot yourself in the foot with health checks. If you put an health checks on your homepage and it goes in the database and goes back, that's a bad health check. If you put health check in, I don't know, an external dependency and it goes wrong, and then you have a cascading failure, and that's a bad health check. So do health checks, of course, but do them wisely and build something that's really easy to start, and then build upon this while taking data from your observability stack, logs and metrics, and etc. Here, for instance, I just run a curl on the two entry points, the API and the main endpoint, knowing that it's really, really easy and it can time out. So I'm also giving it a large amount of timeout so that I don't want to have some kind of cascading failures.
Yeah. So as I mentioned, it's easy to shoot yourself in the foot. And that's because you don't want to stress your application while it's trying to load. And there is no right threshold there. Depends on how fast is your application or how slow it is. And you need to figure out the metrics by yourself. Kubernetes is leading the way in this. It's proposed a lot of readiness probe, or probe basically. Readiness probe, basic for the health checks, liveness, if the application is live or not, and startup. And this was added recently, or quite recently, basically for slow startup application. We want to move some legacy application that takes a couple of seconds or few seconds to run. So you want to have this, give it a lot of time basically before it can serve traffic. So that it's pretty handy when you use it. And again, use observability tool to gather data, to not stress your application, because I've seen it a lot that sometimes your application starts slowly and you over-stress it, so your application is basically entering this endless phase of rebooting. Yeah, thank you for bearing with us. The Dockerfile that we are running is one single process. I know that traumatized a lot of people, so finally we're going to get rid of it and split it. Show us the magic.
Yeah, because right now all we wear is result-oriented, okay? Yeah. So let's say you have this big launch or a big marketing campaign and you have tons of traffic coming in. You cannot scale this as a unique container, because what is in the container? Everything. You have a godlike process like supervisor D or system D, and everything is in it. The API, the front end, the back end, the database. So when you have this kind of coupling, it's very hard to scale accordingly. So what we are going to do finally is to split the Dockerfile in many Dockerfiles and rule them all with one Docker compose YAML. So this has been in production since 2015, since I started containers, and this has proved very, very interesting because you have this tiny YAML and it expresses all the stack. So the stack now is only a couple of lines. You have the DB, the words, and the web services, and it's very easy to make sense of it. As for the Dockerfiles, they are now written in their own folders. So let's take, for instance, the web frontend. See how it's very tidy. It's still running and linting and asserting with Aboullaite and other tools, so it's doing great. And all I have to do here in my build ship run now is to use the Docker stack deploy. With this, I can deploy my services and run them with secrets, and everything now is quite scalable, because as the last example, I'll tell you that, for instance, I decided to scale up to 3 replicas for the words service. So it's very easy, and I encourage you to use it. It's very interesting to do this in development, but also in production, because you can go to Kubernetes very easily. And you can see here that all my containers are running. And yeah, it's finally production ready.
Yeah, I miss how Docker Swarm was easy to use. Nevertheless, it is basically back to the single responsibility principle. you want to, depending on how you want to split your architecture application. I know now we're in the discussion of going back to monolith and stuff. That's a discussion for another day. But yeah, single responsibility, keep the Docker files or how to build your Docker logic near where your application is. And there are a lot of container orchestration tools that enable you to deploy your application. And you can basically use other tools such as Customize, Helm, and stuff, basically it enable you to add variables to your Helm or container orchestration deployments. Basically, those are Kubernetes native tools to variabilize. I don't know if that's a word, but add variables basically to your Kubernetes manifests, so they can, instead of copying your files per environment, you only change variables, which is pretty handy, more nicer in the developer experience. And finally,
the most important thing.
Yeah.
I cannot. I have to tell it.
So imagine that you have been running your application for a long time, and then you got hacked, and you appeared in the news. Yeah. That's something we don't want. So what we can do in that sense to avoid such great.
So don't go in production without this step.
Okay,
the last one.
Jalal, we have 1 minute left. I don't know what we're gonna do.
I know. I'm gonna do it. Look, give me 30 seconds. All you have to do is to sign your images to prove that you really produced them. So you have to prove it, and for this we're going to use Docker Content Trust. It's a feature that lets you programmatically sign your images, and then block any other images that are not signed to be run in production. You cannot run any image in production, and that's what we want to do. So it's very easy to scan for CVEs, and it's also very easy to inspect images. See?
Docker Scout is basically a new, traditionally it was known as Docker Scan. I'm not sure how familiar with Docker Scan, but it was replaced with Docker Scout now. Docker Content Trust basically enable you to, when you want to push the image, it sign it with your private key. When you want to pull it later, either deploy it or just check it, you need Docker Content Trust Notary or whatever you're going to use. Basically check those signatures, make sure that you have the key basically, and make sure that the content that you're pulling is the content that you wanted and nothing changed meanwhile. The last one, give us 1 more minute. We're going to skip this part. That's the happy ending. And what I promised in the beginning, you probably don't need a Dockerfile. The Docker ecosystem, or the container ecosystem, sorry, has evolved a lot since 2013 when Docker was first introduced. If we can run 2 slides, basically, of how you can run or build a container in 2023, probably we're going to need a whole presentation. But we're going to demo one final tool, which is Jib. How many of you are Java developers? Not that. Cool, a lot. So basically, Jib, it enables you to build container images without the need of Dockerfile and without the need of Docker daemon inside of your machine. It's basically build your image with best practices and deploy it or push it to your registry. I know Andres is not here, but he won't like me using clean package. He always push for verify. But you can see here that we are building the image. We are basically pushing it directly to the container registry. We have a couple of warnings. I know in the keynote say that you need to worry about your warnings. And then if you run dive, please.
Which one?
The
last
image
one. Okay, let me find it for you. Docker.
Doesn't matter.
Where is it? Oh, here it is. Okay.
Yeah. Basically, we're building a Java application, and you can see that it came with best practices out of the box. It basically splits my application. It's downloading. It splits my application into multiple layers, and you can see that basically downloaded the base, and then it put the dependencies or resources. Dependencies that I'm going to use, then the resources, and then finally the code, which, as we mentioned at the beginning, helps to speed up the build process and generate a smaller image. That was it. Was longer than we expected. Those are the resources. Ready to check your questions. We're out of time, but happy to take them.
And we have free stickers too if you want to.
Yeah, we have free stickers. Yeah, go ahead.
You mentioned the software building materials as a way to manage your tags. What happens if you don't change the version of your product when you fix a bug? Will it have the same tag then?
No. Even if your features are the same and you don't change your code, the Docker image will rot and you will have to upgrade it, and it's another version, so it should change accordingly, okay? It's not only your code, it's also...
Yeah, but let's say that nothing updates.
Okay, so it should be the same tag.
Okay.
Yes, definitely.
Unless you didn't specify the version is in your Docker image. That's an issue. Because like in your Dockerfile, if you didn't specify
the SHA.
no, not the SHA, but even if you are downloading something, apt like run apt get.
Yeah,
so that's mean that you have a new version of whatever software you are downloading. That's in the basically this SBOM gonna be another version.
Okay.
Okay, I think we're good to go.